Hello, this is Mrs. Scarpel, and in this video I'm going to show you the graph of the function f of x equals e to the x. E is that value that relates continuously compounding, whether it be interest, some continuous exponential growth, and some continuous exponential decay. It has a value of approximately 2.1828. We will use the e function of the calculator. It is located with your natural log button. You have to press the blue second button and then natural log to get the e. So I will be using the calculator to help me create a table so that I can then plot some points on my graph and show you the shape of the graph of e to the x and also talk about some features. So let's start with e to the negative 1. E to the negative 1 in my calculator is going to be second natural log. Remember, the negative button is that one below the 3, and we want negative 1. So e to the negative 1 power is approximately 3.68. I'm just going to go out 3 places. So 3.68, or 0.368, excuse me, for e to the negative 1. Now, e to the 0 is something we should be able to do without a calculator. Remember that anything to the 0 power is going to equal 1. So that's just like any other exponential function we've had. When we replace the exponent with 0, our value becomes 1. E to the 1, that's where we're going to see what that approximate value is. So just to make sure I've been saying it correctly, let's just go ahead and use the calculator to find e to the first power is approximately 2.718. So just as I have been saying, write that a little bit better so you can understand what I'm writing. 2.718. We're going to do the same thing for e to the power of 2 and e to the power of 3. So e to the power of 2, second natural log, or e squared, is approximately 7.389. Approximately 7.389. And then let's do that again for e to the third power, or e cubed. Second natural log, e to the third power, is approximately 20.09. So let's plot these ordered pairs. I'm going to use red. When x is negative 1, we are just below halfway, so just below 0.5. At 0, we are at exactly 1, which we would expect for any exponential function. At 1, we're at approximately 2.718, so slightly more than half. 2, we're at 7.389, so just below 7.5. 1, 2, 3, 4, 5, 6, 7. And it does not appear that I'm going to be able to go up to 20. So we are going to have a curve. Let me see if I can write it a little bit better here. We're going to have a curve that looks something like this. So what we would expect for an increasing exponential function. It's never going to get to exactly 0, so we call this a horizontal asymptote. So that's one of the features we need to know, that we have a horizontal asymptote. Remember, an asymptote is a line that our curve does not cross. So horizontal asymptote and we can write the equation for that. Yes, it is the x-axis, but the equation is going to be a y equals equation. So a horizontal asymptote at y equals 0. We also have a domain. I could use any value of x. If you notice, I put arrows on the ends of my curves, so that means it's going to continue to climb up but also get wider. This is going to continue over into the negative direction, off into infinity. So our domain, if we write this using interval notation, will be negative infinity to infinity. So domain, that's x values, is going from negative infinity to infinity. Our asymptote that we have helps us with defining our range, which is made up of the y values we get closer and closer to 0, but we never get to exactly 0. So our range is going to have parentheses 0. And we can see from our graph it's going to continue upward, so off to infinity. So from 0 to infinity is the range of the graph of e to the x power. I can also say that from the left to the right, as I follow my curve, this is an increasing function. And just as with any exponential, we are going to have a y-intercept at the point 1, 0. So these are key features that you need to keep in mind for the exponential function. These features actually work for any exponential function that has not been translated vertically. This one has not been translated. If we were to add something to the end of e to the power of x, remember that would be a vertical translation. So our asymptote would no longer be at y equals 0, but it would be at y equals some other number, and our range would begin with that number. And this concludes our video on the graph and features of f of x equals e to the power of x.